Hey, it's me again. So this is part 2 of this kind of chapter 1 wrap up. I'm going to try to keep them in kind of short segments as to not bore you to death. All right, so let's move into talking about food production a little bit because, again, this is one indicator of biodiversity. And this is related for humans. This little talk here is going to be all about how do we nourish the human population. The three biggest crops in the world are wheat, corn, and rice. If you guess, probably here in the United States, wheat and corn are our top two, definitely. And actually, most of the corn that we grow is not actually meant for human consumption. It's used in cattle feed, in animal byproducts, and stuff like that. But this is referring to human population needs. We have had some history of food shortages, especially, and there was some in the 80s and the 90s, and recently you can look up that if you're interested in it, but there have been some food shortages, and that has led to higher food prices. If you think back to March, whenever the pandemic first hit, remember when toilet paper was impossible to find? Yeah, I know it's not food, but tied to that were other products and things like chicken and pork and meats and things like that. Their prices actually went up quite a bit because workers that were working in those facilities that processed things like pork and chicken especially, they were getting sick with COVID and they were not working. And so therefore the production went down, and that led to higher food prices in those products for a while. Okay. Average global surface temperatures and carbon dioxide concentrations. There's a lot of greenhouse gases, we know that. And what happens is these greenhouse gases get trapped in our atmosphere. That's the definition of a greenhouse gas. There are several of them. Obviously the one that you hear about the most is carbon dioxide. There's other ones as well, which we will get into. Methane, CH4, there's not nearly as much of it, but it is so much more harmful in terms of trapping the gas. It is a lot better at that job. So even if any increase in the amount of methane will really up that, it can do a lot more damage. And the whole purpose of this is that we want a nice moderate amount of greenhouse gases, not too much, because it helps us kind of stay in that Goldilocks zone of a nice temperature range where we can live, not just we, but other organisms as well. And there's tons and tons and tons and tons and tons of evidence that this has risen over time, mostly because of anthropogenic reasons. If you don't know what the word anthropogenic means, add it to your vocabulary. Use it at dinner tonight. Anthropogenic means human caused. So using and burning of fossil fuels, those are big, big ones. Again, don't worry. We're going to get into all of that. Human population. Wow. Okay. So when the book was written, it was at 6.9 billion and growing. And remember, your book is from 2012. The new books we will be getting will have an updated number here. Obviously, it's over 7 billion now. So, and it just keeps growing. And so right now, just kind of keep that in the back of your head. Right now, as of March 2020, it was estimated that the human population was 7.8 billion people. Yeah. With humans has also come along with the concepts of the agricultural revolution and the industrial revolution. That has really helped our population grow almost exponentially because we've been able to use, to basically provide food for people more, I don't want to say easily, but definitely using fewer resources. And the Industrial Revolution has allowed us to produce items in mass and bulk, and that has allowed people to become much more independent and not need to just live off the land. All right, resource depletion. So this is a sad one. As there's more and more people, the resources that are required to help support our growing population continues to go up, right? That makes sense. More people, more resources. And so what we're having to do is, one, we are coming to the realization that we're not doing that sustainably, meaning that at a rate which we can maintain that and it all recycles up back together and it works, okay? No, we're not doing that. This goes back to your ecological footprint. So if you think about what your overshoot day is, that is referring to how far into a year you could exist with what resources we currently have on our planet. So let's say if your overshoot day was, say, I'm just going to toss it out there, May 28th, then that means that you could live with your current resources until May 28th. And then after that, you are digging a hole in those resources. They are not there. It's like you're buying them on credit. And most, especially of the modern world, we are all doing that. Some a lot more than others. And so we need to take into account things like renewable resources. And we also need to take into account things like those non-renewable resources that once we use them up, there's no more. So we need to be innovative, right? And trying to become more sustainable. All right. So this brings us kind of back to that whole tragedy of the commons, right? So we have our TOTC here again. So remember, the commons is what we all have access to. The tragedy of that is whenever we overuse those resources. And a lot of times it's because there's no checks and balances, whether that's humans and legal issues or greed. There's all sorts of things. And can this happen in the natural world without humans? It can, yes, but we have really exacerbated the rate of which these exploited resources have been, like, basically just a lot of things eradicated because of our greed. Here it says Garrett Hardin. He is the original author of this concept. And Easter Island is a very common example in which we will kind of refer back to when we come back to this topic. So here is our ecological footprint. So you guys have done this. And so it's, how sustainable are you? And are you? I'm raising my hand to say I'm not. Most of us are not, especially if we live in a first world country. Third world country inhabitants actually are a lot more sustainable at their living lifestyle than we are, because we are, in a way, greedy. We like to drive. We like to buy food that has been transported over long distances. We like our electricity. Yeah, it gets complicated. Okay? The human ecological footprint as a whole, if you look, it's about 125% of Earth's total usable land area. Now you may be thinking to yourself, what the heck does that mean? Okay, so what that means is that most humans need 1.25 Earth to really live, to be sustainable. And that, by definition, is non-sustainable or unsustainable. We have to be able to get to the point where we have 100% of Earth's total usable land area as our human ecological footprint. And again, this is where the innovation piece comes in. All right, as an introduction, we're also going to touch on parts of the scientific method. One of your free response questions is geared completely on this. You may have to write a scientific experiment from beginning to end. You might have to be hypothesize 2 or 3 different hypotheses that may work for a specific given information set. So this is something we're going to come back and practice all year. And you guys will be doing some exercises with this week as well. So controlled versus natural experiments. Controlled happen in things like a lab, in a classroom, we can absolutely control those settings. So instead of being able, if you can't go out to a pond and run specific tests and stuff like that, well, you might be able to set up fish tanks that could basically resemble the pond in every possible way. Okay, you're reenacting it. Whereas natural experiments do happen out in the environment. But the difference here is that if it's controlled, you can control things a lot more easily. In nature, you have a hurricane wipe through and bust open gas lines, and that gas gets into the water source that you're needing to test, you cannot control that. So that's something else that really becomes a big factor. So natural experiments, like this example here of a volcano, well, yeah, that, whoopsies, maybe you have to go find another volcano or wait for it to regrow or something like that. So here's some unique challenges that we see in this topic. We don't really have a control Earth to compare everything to. We are the experiment. So that's one of the reasons why it's so unique and challenging and critical that we get it right, because we don't have a second go at this. It's very subjective, meaning that people have different viewpoints as to what they think is acceptable. Everyone has an opinion, as they well should, but those opinions and that subjectivity can really alter the way that people's outlooks are and theories and belief systems. The interactions we have with each other and with the natural world around us are very challenging. Some cultures are much more one-to-one with nature. They take it and they try to thrive in it the best that they can without changing and altering it. And then you have Americans, example. We interact with it in a way that we, unfortunately, kind of annihilate great parts of it so that we can feel more comfortable. And human well-being. We also have to take that into account because at the end of the day, we are part of this big scheme. So there are 3 ways we can get a sustainable development here. We need to have environmental systems that can easily recover. We need to have renewable resources that can be regenerated at a rate which before they are depleted. And we need to very sparingly use our non-renewable resources. All right, so those are my big concepts and takeaways from chapter 1. We'll definitely dive into other tidbits here and there. So this is ending the mini lecture for chapter 1.